Welcome to this video on free body diagram. Free body diagram is an application that is included in the learning tool for engineering statics. You can download the learning tool from this link, and after you download and install, you can run the statics power software. This is the front end of the software. If you click on the free body diagram button, you will activate the application. The free body diagram software can do three things. It provides you with drawing tools, and you can build frames and machines on the screen, and then it can draw free body diagram, and it can also show the solution strategy. This is the building workspace, and at the top you have some buttons for various actions, and this is the empty workspace. Let's focus on some of the buttons. There are some member buttons like a straight member, L-shaped member, and T-shaped member. You click on a button and then you drag the member into the workspace. You can grab the endpoint of a member and stretch it, rotate it to get the shape that you want. There are two kinds of joint buttons. One is a pin joint and the other one is a clamp joint. So here we have two members overlapped, and we can insert a pin joint here or a pin joint here, or you can use the clamp or fixed joint to make various shapes. There are 5 kinds of supports: pin support, contact support, clamp support, and 2 kinds of roller supports. You can insert a pulley in your free body diagram with the pulley button, and once the pulley button is inserted, it already comes with 2 cables attached to it, and you can click and drag the ends G or H to change the direction of the pulley and the points of contact. The cable button can be used to insert a cable in your structure, and when you insert a cable in your structure, you use the pin buttons to fix the cable to the rest of the structure. You can apply 3 kinds of loads: couple, distributed loads, and point loads. Among distributed loads, you have 3 options: constant, linear, or quadratic. And for point load, you can locate the point load on a member by setting these distances from the 2 nodes, let's say A and B, and you can change the angle of application of the load by using the rotation utility, and you can set the magnitude of the load. So we can build a frame, an A frame like this, and by inserting 3 straight members, putting points, pins at these junctions, applying a roller support and applying a pin support, and then we have added some loads on this structure. Then you use this button, which we call the explode or free body diagram button. When you click on this button, the software will draw the free body diagrams for you. For the A frame, it draws 4 free body diagrams, one for the whole body, one for the left arm of the A-frame, one for the right arm of the A-frame, and one for the horizontal member of the A-frame. When you build a structure like this and try to draw its free body diagram, the software will warn you that the structure is not statically stable. So free body diagram software can identify statically unstable structures, indeterminate structures, and also determinate structures. The software can identify two force members. It doesn't matter what their shape is. For example, here we have a Z-shaped member, but just because it's connected to the rest of the structure only at 2 points, 1 and 2, and no load is applied on this Z-shaped member, the software knows it's a 2-force member and applies only 2 forces that are along the line joining these 2 points of application. When you draw a structure like this and click the FBD button, it will draw the free body diagrams of the members and some relevant pins. For example, here is a pin on which a load is applied, so we will get a separate free body diagram for that pin. Here is the load, and these two are the internal forces in the structure. You can draw a structure with a pulley. Click the free body diagram button, and it will draw the free body diagram of the entire frame, the horizontal member, and the inclined member. Software shows solution strategy for frame 3. So for the third frame that we showed for this frame, and it will tell you how to find the internal forces that are acting on various members. So the computer solution strategy, it says you have to solve member FG first, then go to member BEF, member EC, pin C, and pin B, and so on. You can also build machines, at least in a skeletal form. For example, here is a pliers, and we have drawn a skeletal form of the plier by using straight members and a clamped corner and with a whole bunch of pins. And the software can draw the free body diagram of the 4 pieces in that plier. That concludes this video.